Yeah. Okay. In the last class, we have started our discussion on block diagrams. So, particularly, what is this block diagram? It is nothing but what to give a pictorial representation of a physical system. One particular physical system is nothing but block diagram. So, this block diagram will give a pictorial representation of a physical system. Either it might be any type of system. So it will show the pictorial representation. We will represent the one particular physical system with the help of this block diagram. Fine. So what is the use of this block diagram? Which is used to represent one particular physical system is nothing but the or simply it is nothing but a pictorial representation of a one particular physical system. We calling it as a block diagram. So when we drawing the block diagram of a one particular physical system, here in the block diagram we are having some elements. So to draw the block diagram, some elements are required. That is, one is a block, another one is a branch point, another one is a summing point. Is it clear? One is a block, another one is a branch point, another one is a summing point. In this block diagram, all the system variables are linked to each other through functional blocks. So system variables will be linked to each other through this functional blocks. Already I have discussed about what you mean by this block in the last class. I have already discussed about this blocks. Are we calling it as a functional block, or we calling it as a simply a block? So this is a block, and to this block we are giving the input and we are defining the output. Output is nothing but the output of this particular block is nothing but what? B is the output, that is nothing but A into a gain of this block, that is nothing but G of S. Is it clear? So this is about the functional block. Now when we talk about the summing point, particularly what is the use of this summing point? First one, here when we are representing this one, first one what we are having is block. Okay na, in the block diagram, first one we are having a block. Next what we are discussing about the summing point. Summing point is nothing but what? It is used to add two or more signals in the system. So here A is a system, A is a signal and B is the signal. So with the help of this summing point, I am adding or subtracting these two signals. So based on this plus and minus, I can add, and if you are having plus and plus, I can I can subtract or I can add based on the reference here what we are having, positive sign or negative sign. Here we are having a negative sign. So what I am doing is having a minus b. A is the one signal and b is the another signal. The difference of this I am getting is the output of this particular summing point. Is it clear? Yeah, the plus or minus sign at each arrowhead indicates whether the signal is to be added or to be subtracted. It is important that the quantities being added or subtracted have the same dimensions and the units. Is it clear? This is about the branch point, and this is about the summing point. Next, branch point. So this is nothing but the branch point. uh, is a point from which the signal from a block goes concurrently to other blocks, or the summing point. So here this is a point. So from this the signal goes to that particular any block, or goes concurrently to other summing points based on this one. So here this is a branch point. From this one signal is bifurcating here, so it can goes to a particular summing point here. So we can have a summing point here, or else uh, we can have a branch also, no problem, or else we can have a branch also here, some block diagram also, functional block also here. Or else if you not having, if you having a block and the gain of that one is G of S. So what is the output here? We are having A into G of S is the output, right? A into G of S is the output here we are having. Now in this case what we are having is, we are not having any block or any summing point. So that is nothing but the output is same what is the input what we have given, that is nothing but the A is the signal. Here also the signal what we are having is A is the signal what we have. If we have a function block or a summing point, uh, it will be different. Now for constructing block diagrams of a control system, So uh, particularly what we supposed to do, we supposed to use this differential equations governing the system. So fine. So with the help of the differential equations what we having, with the help of that one we can construct the block diagram. Now by taking the Laplace of the differential equations are converted into algebraic equations, so the equations will have a variable and constants. From working knowledge of the system, the output and variables, output input and output variables are identified, and the block diagram for the each equation can be drawn. So later it will be clear for you this concept while we are drawing the block diagram. So this already I have discussed how we are constructing the block diagram of a armature controlled DC motor, and how we are constructing the block diagram of a field controlled DC motor. This we have discussed. Now we'll just discuss some more concepts. Why? Because see, having a block diagram of a one particular physical system, either any type of physical system I having, and I know the block diagram of that particular physical system. Now a question is that I want to study the particular system. I want to know the analysis. I want to know the knowledge of that particular system. I want to study the uh, system. So in what way I can study? With the help of the transfer function I can study the analysis of the system, right? Now the thing is that whatever the block diagram I'm having, I supposed to reduce that block diagram in a in a in a by using a certain rules, and from that rules what I supposed to do is I supposed to write the transfer function. So for reducing the transfer function, for reducing the block diagram, to find the overall transfer function of a system, we having certain rules. Is it clear what I'm saying? I having the block diagram. Now the thing is that I want to study the system. So how come I can study the system? I supposed to go for the transfer function approach. Is it clear? So to find out the overall transfer function of a particular system, what I supposed to do? First of all, I supposed to reduce the system. I supposed to reduce the block diagram. After reducing the block diagram, I can find out the overall transfer function of the system. Is it or not? So now to reduce the system, to reduce the block diagram, having certain rules. So these are the rules. We are having certain rules. So there are the certain rules got framed such that any modification made on the diagram does not alter the input output relations. Is it clear? So first of all what I am doing is, by using certain rules which have framed, I am reducing the block diagram, and after reducing the block diagram what I am doing is I am finding out the transfer function. I am finding the overall transfer function, right? So total how many rules here we are having is total 11 rules we are having. So if you are perfect, if you having a good knowledge about all these 11 rules, it is very easy for you to reduce the block diagrams, and you can find out the overall transfer function of the block diagram. Now the first rule what we are having is combining the blocks in cascade. So first one what we are supposed to do is, when the blocks are in series, what we are supposed to do? So here we are having the blocks which are in series, so combining the blocks in cascade. So we are supposed to take the product of that blocks G1 and G2. Is it not? Gain of this block G1 and gain of this block G2. So I am just taking the product. So finally output what I am having is A into G1 G2. Combining the parallel blocks, here I have combining the series blocks. Now what I am doing is I am combining the parallel blocks. So these are the two blocks which are connected in parallel. I have connected one summing point over here. We are having one summing point over here. So finally the output of these blocks what we are having, this is a branch point. I hope so everyone having a clear idea, right? So this is the branch point. So this branch point, this signal is going to this particular functional blocks, and this signal is going to this particular functional block, and output of this one is AG1 and output of this one is AG2. Now what we are having here in this case, I am having the summing point. So here the symbol I have, here the sign I have taken the positive sign. So AG1 plus AG2, is it or not? A I have taken common. So this is the final output what I supposed to get, what I supposed to have. Now what I am doing is I supposed to combine this parallel blocks. So here what I supposed to do, input is a signal and I can, in parallel means I can add that a g1 plus g2. So finally the output what I am getting is a into g1 plus g2, that is similar to the previous case what we have. Is it clear? Now next, moving the branch point ahead of the block. So here I having the branch point, I supposed to move this branch point ahead of this particular block. So in such a way I supposed to move. So here I not having any, for this particular branch point I not having any effect of this g. So the whatever the input signal I am getting, the output is also the same. Now if I moved here means what happens, it having a effect of this particular g, particular gain g. So what I am doing is 1 by g, another block I am taking, functional block, in that the constant what we are having is 1 by g. So finally the output what we are having is, yeah, a is the output, which is similar to here what we are having. Is it clear? Now moving the branch point before the block. So here I having the branch point. Now the thing what I supposed to do, I supposed to move the branch point before this particular block. So now here for this one it having a effect of g. If I move here, effect of g won't be there. So again I am considering one more block. In that one more block I am taking this gain g. So finally the output here will be both same. Now this is important, moving the summing point ahead of the block. Now here this is the summing point what we are having, I supposed to move this summing point ahead of this block. So when we talk about this summing point, here it not having any effect of this g. Is it clear? So what I supposed to do, if I move this summing point ahead of this one, what I supposed to do here, I have to introduce this functional element, that is functional block here g. So finally what I supposed to get is bg and ag. Here I am using one, here the summing point what we are having. So from that this is the final output what we are having. In both the cases the output will be same. And moving the summing point before the block. So I am moving the summing point before the block. So here it having the, it does not having the effect of g. If I move this summing point over here, what I supposed to take, I supposed to take 1 by g. Is it clear? I hope that it is clear for you. So finally the output will be same in both the cases. So here I am moving the summing point before the block. This is the block, before the block I am moving. So if I move the summing point before the block, what I supposed to do, here I supposed to arrange this one, 1 by g I supposed to take. Now next rule what we are having is, we are having interchanging the summing point. Here we are having the two summing point, this is the one summing point and this is another summing point. Here we are supposed to interchange the two summing points such that the output supposed to be same in both the cases. Now even though I am interchanging the two summing points, whatever the output here we are having, it will be same in both the cases, right? A plus b minus c, here also a plus b minus c. So that is the interchanging of two summing points, that is the one more rule what we are having. Next rule number 8, splitting the summing point. So I can split this summing point. So a plus b here and a plus b, this is one summing point I can take, this is another summing point. So finally the output what we are having is a plus b minus c. Now combining the summing point, this is the summing point what we are having, I can combining the summing point. Similarly here we are, how we are splitting, in the same way we are, for this one we can combine the summing points. Now elimination of negative feedback loop. So we supposed to eliminate this negative feedback loop. So this is the final system, final reducer system what we have, block diagram what we are having. So how we are eliminating this one? Yeah, what we doing here? So look carefully here. Here we are having a summing point. The input reference is R is the input what we are giving, and the feedback what I am getting is CH is the feedback. Now here the error signal what we are generating here, that is nothing but R minus CH. Is it clear? This is the thing what we are having. And here we are having one more functional block. That error signal is given to this particular functional block. So this is the output of that particular functional block what we are having, G into R minus CH. Now this is C is nothing but what? C equals to what? Yeah, I hope that C is nothing but R minus CH into G. Is it or not? Or else this can be written in such a way, RG minus CGH. So now what I am doing is I am just bringing this CGS over here, so it will be this one, RG equals to C plus uh, CGH. So now what I require is the final transfer function. What I require, C by output by Laplace transform of output by Laplace transform of input, right? So C by R I require. C by R is nothing but what? G by 1 plus GH. Is it clear? So this is the elimination of negative feedback. Now elimination of positive feedback. Just please everyone go through. So elimination of negative feedback, what I am getting, C by R is nothing but G by 1 plus GH, and C by R here is nothing but what, in the case of positive feedback, G by 1 minus GH. Just go through this one now please. For a while I will giving you time. Just please everyone go through this. It is clear everyone? I hope that everyone got a clear idea about this one, right? So here rule number 2 indicates the elimination of negative feedback, whereas rule number 11 will resembles the elimination of positive feedback. So here the transfer function, overall transfer function C by R what we are having is G by 1 plus GH. In the case of elimination of positive feedback loop, C by R what we are having is G by 1 minus GH. Is it clear? Now here we will discuss one problem. Reduce the block diagram shown in figure and find C by R. Yeah, for this one you want this one, right? See here, what is the error signal here we are having? I am just writing R plus CH is the error signal, right? R plus CH is the error signal. Now what will be the output of this block G is nothing but R plus CH into G. Is it clear? R plus CH into G. Now what I suppose to write here, C is nothing but what? R plus CS into G is right. So finally what I supposed to write here, this will be nothing but what? C equals to, finally what I supposed to write, I can write in such a way that okay, C minus CHG, C minus CHG. Is it clear? So sir, one second. C minus CHG equals to, finally what we are having, RG, right? This is the thing what we are having final from the mathematical analysis. Now what I require is I require C by R. C by R I require. So C by R is nothing but what? G by 1 minus GH. This is the thing what I get. Is it clear? Please. Now it's okay? Fine, fine, fine. Yeah. Now we'll have some more example problems, some example problems over here. See, here what we are having, reduce the block diagram shown in figure. So this is a block diagram what I having. I supposed to reduce the block diagram which is shown in figure. This is a block diagram. I supposed to reduce the particular block diagram, and I supposed to find out C by R. Is it clear? I supposed to find out this transfer function. That is nothing but Laplace transform of output by Laplace transform of output. This is the thing what I supposed to find. So first of all, what I supposed to do here? How come I can reduce here? Having the rules, by using that rules I supposed to reduce this one. Just think what I supposed to do here. Please everyone think what we supposed to do here. So first of all, what we supposed to do here? So this branch point can be moved here, is it or not? The same thing. Here this is a branch point. I am moving branch point ahead of this particular block. So what I supposed to mention here? So here I supposed to create another block, that is 1 by G. So in such a way I can do. So now I can eliminate this path, this negative feedback path I can eliminate, and also this one also I can eliminate. Blocks which are in parallel. So this is the thing what we are having. From this, what will be the transfer function? G1 G2 plus G3 by 1 plus G1H. Is this clear? Anyone having any doubts here? Please respond to me, this is important. Please everyone try this by your own. Please ask me if any doubts you having, just please try once. Yeah, please everyone try this. Just find out now itself everyone find out this C by R. Please everyone find out C by R. So this is a basic block diagram reduction problem. If you know this, the rest problems will be easier for you. You got the answer for this one? Please respond to me. See, again I am repeating here the simple steps what they have followed. See, this is a block diagram what we have. Here particularly we can't eliminate this one. We can't eliminate. Why? Because here we are having a branch point what we are having. So for that purpose what we are doing, first of all I am just moving this branch ahead of this particular block. See, I am just moving this branch point ahead of or after the particular block. So this is the thing what we are having. Now what I supposed to do? This feedback path I can eliminate, and this parallel blocks I can combine. So the same I am doing here. So this is the transfer function what I am getting by eliminating this feedback path, and now by combining this one, what I supposed to get? G2 plus G3 by G1. So this is the final overall transfer function. Just please everyone do this one. Everyone please reduce the block diagram which is shown in figure and find out the overall transfer function of the particular system. How you going to reduce and how you finding the transfer function of this overall system? First of all, what we supposed to do over here. Please everyone try this once. See here in a control systems, you a lot of practice will make you perfect. If not, you will be get confused. So you supposed to keep on doing the practice. Then only it you will perfect in this particular reduction techniques. Fine, block diagram reduction techniques. Please everyone try this. Reduce the block diagram and find out the overall transfer function. Is it clear? So first of all, what we supposed to do here? So by looking this particular figure, if see here, if you move this branch point here, so what we can do here, moving the branch point before the block. So I'm moving the branch point before the block. So if I move the branch point before the block, so we can combine this parallel path. Is it clear? This parallel path will be get combined. Fine. Next, what I am doing here, this summing point I am moving before the block. Is it clear? By using the rules what we are having, and I am just moving this summing point before this particular block. Now after moving the summing point, I am just interchanging the two summing points. So this is the thing what we have. Now what I am doing is, I am just eliminating the feedback path and I am combining the blocks which are in cascade. So this is the final thing what we have. So from that, this is the transfer function what I am getting. Just I have given a high level idea about this, about the reduction technique. I hope that now you can solve the problem. Just solve the problem now. If any doubts you can ask me. Just please everyone take this sorry, yeah, please everyone take this block diagram and solve that. Make it fast. Got completed? Make it fast. Please respond to me. Are you clear what I'm saying? Everyone have a clear got a clear idea about this one? Please, any one of you respond. You got the answer? Have tried this one? Yeah. One more problem here we are having. So this is the transfer function. This is the block diagram what we are having. We are supposed to determine the overall transfer function of this particular block diagram. That is C of S by R of S. We are supposed to find. Just try this. Try this one, please, everyone. What we are supposed to do first of all? So we can move this branch point ahead of this block, right? So this branch point can be moved ahead of this block. Is that clear? So after moving this one, what we supposed to do? This part can be eliminated, and next this part can be eliminated, and finally this part can be eliminated. Is that clear? That is a simple way. Just try this one. Please everyone try. I will discuss the answer later. Please everyone do this. So first of all, this branch point I am shifting over here. Is it clear? So after shifting the branch point there, what I supposed to do is, first of all, this can be get eliminated, this block can be getting eliminated, and next this one can be get eliminated, and next finally this block can be get eliminated. Is it clear? Or else here what they did, anyway we can do here, particularly what they did, they just brought this block this branch point before this block. See here, this branch point is moved before this one, or else we can move this branch point over here, or else this branch point will be shifted over here. See, now what they did after shifting that one, just they rearranged it in such a way, this path can be eliminated and this path can be eliminated, this feedback path and this feedback path can be eliminated, and finally this entire loop got eliminated. And fine. So this is the final transfer function what we are having. I hope that it is clear for you. Now one more example problem here we are having. So just I'm moving to the next topic. Yeah, we'll see, check once. So for the system represented by the block diagram shown in figure, determine C1 by R1, C2 by R1. So we supposed to determine C1 by R1 and C2 by R1. We supposed to determine this one, C1 by R1 and C2 by R1 we supposed to determine. So this is the block diagram what we are having. This is the block diagram what we are having. Is it clear? So first of all, what I supposed to do here, how come I can represent this C1 by R1? So to find C1 by R1, here we supposed to take this R2 equal to 0. This R2 is considered to be 0 here. So when R2 is 0 and only one input C1 is considered, we can remove the summing point which need not connected this. Is it clear? This summing point is need not connected. Need not connected. Need not consider G6 and G6. G6 and why? Because this G6 is on the open path. G6 is on the open path. Is it clear? This is not required. Why? Because it is on the open path. We supposed not consider for this one. So finally this is the block diagram what we are having. Now what I supposed to do, this is not there, so what I supposed to do here, this can be get eliminated. Is it clear? Yeah. Now after this one what I supposed to do now, this entire thing what we are having can be get eliminated. Is it clear? Positive feedback. So finally this is the block diagram, the reducer block diagram. Now whatever the blocks here we are having, I am just combining the blocks in cascade. So this is the final block diagram, reducer block diagram what we are having. So it represents the negative feedback path. So just what I am doing is I am just eliminating the negative feedback path and I am combining the blocks which are in cascade. So this is the final thing what we are having, final transfer function what we are having. when for C1 by CR1. Now C2, to find C2 by R1, what I supposed to do, this R1 I supposed to be, in this case also I supposed to set this R2 equal to 0. Is it clear? So and consider only one output. This output I supposed to consider. This is not there. Why? Because it is open. C1 will be 0. I am not considering this one. So only one output, that is C2, I supposed to consider. Now again the same, what we supposed to do, we can remove the summing point, which need not consider this G3 and G3. Why? Because this G3 is nothing but open path. So this is the resulting block diagram. This is the resulting block diagram what we are having. Now again the same way what we did here, also we combining in cascade and splitting the summing point. Is it clear? And next, after that one, we are eliminating the feedback path. After eliminating the feedback path, whatever the blocks which are in cascade, we are combining the blocks. Finally, after combining the block, again we are supposed to eliminate this feedback paths. Is it clear? So finally this is the thing what we are having. So from that, this is the transfer function, that is C2 by R1. Is it clear? I hope that everyone got a clear idea about this one. See, you will have a bit confusion. It will be clear when you will do more number of problems, when you will solve more number of problems. It's clear. So this is about the concept of the block diagram reduction. So particularly by reducing the block diagram, we can find out the overall transfer function of a system. Yeah, more number of example problems are there in this particular book, you can refer, and moreover you can refer another books like that, another books, Anand Kumar, Nagarath Kotari also you can refer. Here also in this book also you can get more number of example problems. Yeah. Next topic, we are going to the next topic now, signal flow graphs. So in the previous discussion we have covered this block diagram reduction technique, the block diagram reduction. Now we are going to discuss about the signal flow graph. So particularly these signal flow graphs are used to represent the control system graphically. Particularly in the previous discussion, this block diagram are used to represent the control systems in a pictorial. It is used for the pictorial representation of a particular system, whereas the signal flow graphs are used to represent the control system in a graphically. Is it clear? It is used to represent the system in graphically. Fine. So it was developed by S.J. Mawson. It was developed by S.J. Mawson. So what we doing here in this particularly in this approach, in this signal flow graph approach, so it will yield the same information as we getting in the case of a block diagram approach. So the signal flow approach also yield the same information what we getting in the case of a block diagram approach. But the thing is that one disadvantage in the case of signal flow graph method is that by using the Manson's gain formulae, the overall gain of the system can be computed easily. Is that clear? The main advantage here is by using the Manson's gain formulae, the overall gain of the system can be computed easily. This method is similar than the tedious block diagram reduction techniques. Is it clear? So when compared to the block diagram reduction technique, this method by using this Manson's gain formula, it is somewhat easily for computing the transfer function of the system, overall transfer function of a system. Is it clear? Now here also for knowing that, for first of all, for doing the analysis by using the signal flow graphs. Here also we supposed to follow some terms are very needed. First of all, we understood that we have to understood that some the terms, and here also we are having certain rules we have to discuss, then we can easily solve the problems. Fine. So first of all, what do you mean by the node? What do you mean by the branch point? What do you mean by the transmittance? What do you mean by this input node, output node, mixed node, path, and open path, closed path, forward path, uh, forward path gain, individual loop, loop gain, non-touching loops. So these are the terms what we're having. First of all, we'll discuss these terms, and then we'll focus on the um how we are going to solve the signal flow graphs and how we are finding the transfer function. So first of all, what is the node? We're going to discuss about what is a node. Is it clear? A node is a point representing a variable or a signal. So it is a point which is used for representing a variable or a signal. Just please, any doubts you can ask me. So what is a node? A node is a point representing a variable or a signal. Now, what do you mean by the branch? A branch is directed line segment joining two nodes. Is it clear? A branch is nothing but what? It is a directed line segment joining two nodes. Is it clear? Now, the arrow on the branch indicates the direction. See, this arrow, what we have, it indicates the direction of a signal flow, and the gain of a branch is transmittance. Now next, what is transmittance? The gain acquired by the signal when it travels from one node to another node is called transmittance. Is it clear? Please everyone remember this. What is transmittance? A gain acquired by the signal when it travels from one node to another node. See, for now I will stop here. In the next class I will discuss about all those things in detail, and I will do some more problems. For now I will stop here. Any doubts? Now you can ask me regarding this topic today what we have discussed. I will stop here. Please, any doubts you can ask me regarding the block diagram reduction techniques. Any doubts? You can ask me any doubts regarding this topic, block diagram reduction topic. Yeah, for now I will stop. Thank you everyone. Babu Dheeraj. అటెండెన్స్ తీసుకుంటున్నావా? నాకు పంపి ఎన్ని క్లాసులు అన్ని తీసుకున్నావా? నాకు పంపిస్తావా ఒకసారి? ఇది మెయిల్లోనా ఏదైనా పీడిఎఫ్లో చెప్పి పెడతావా? నీకు ఎట్లా కనుక్కో. రైట్ రైట్ పంపి. యా యా ఓకే. నీకు ఎట్లా కన్వీనియంట్ ఉంటే అట్లా పంపి, కానీ కరెక్ట్ పంపి. నువ్వు నాకు ఆ ఫోటో కాపీ పంపి, మళ్ళీ నాకు మళ్ళీ ప్రాబ్లం అవుతుంది. నేను వచ్చిన సార్ అంటే నాకు ప్రూఫ్ ఉండాలి కదా. మ్మ్. మరి అట్లా ఎన్నో ఉంటాయి కదా ఫోటో కాపీస్ అట్లా. పంపమ్మా. ఓకేనా? నేను ఓకే ఓకే నోట్ చేసుకుంటా. ఓకేనా? సరే అమ్మా. రైట్ రైట్ ఓకే. చెప్పు ధీరజ్, చెప్పు. నేను అదే చెప్తున్నా, మీరు ఇంటలేరు. అవుతున్న సార్ అంటుంటే నేను ఏమంటే చెప్పు. 100 అవుతలేరు అసలు గూగుల్ మీట్లో. మరి మిగతా వాళ్ళు ఎవరు క్వశ్చన్ చేస్తలేరు కదా మరి. కాదు కాదు ధీరజ్, మరి మిగతా వాళ్ళు మేము క్లాస్ వినలేకపోతున్నామని ఎవరు క్వశ్చన్ చేస్తలే కదా. ఎందుకు అంటే జాయిన్ అయ్యేది 100 లోపే అవుతారు స్టూడెంట్స్. అది ఆడ అది వచ్చారు, తర్వాత రావట్లే. వస్తున్నారు. అది బ్లూ బటన్లో తీసుకుంటే ఏమవుతుందంటే మీరు డిస్టర్బెన్స్ అంటున్నారు కదా. మరి ఇంకా వేరే యాప్స్ మీ దగ్గర ఏమున్నాయి? జూమ్లో అసలు ఇప్పుడు జూమ్లో ఎంత 100 మెంబర్స్ చెప్పనా? 100 వస్తారు జూమ్లో, వస్తారు కదా 100 200 దాకా వస్తారు కదా. వచ్చింది అతనికి. మ్మ్హ. వాళ్ళది వేరే అమ్మ, మాది వేరే. అవన్నీ అసిస్టెంట్. అంటే కంప్లీట్గా మొత్తం చెప్తున్నారా కంటిన్యూస్గా వాళ్ళు? మొత్తం మీకు ఎంత 1.5 అవర్ కంటిన్యూస్గా? అంతే కదా మ్యాక్సిమం అయితే మనలాకనే కదా. ఏమి ఓకే ఇంకా అందరూ అంతే ఇంకా మామూలుగా. ఎందుకంటే ఇది ఆన్లైన్ కదమ్మా, ఇబ్బంది ఉంటుంది, మీకు ఇబ్బంది ఉంటుంది అట్లని. ఓకేనా? సరే నేను వేరే చూస్తాను. ఓకేనా? రైట్ రైట్. రైట్ రైట్. చెప్పండి మేడం. చెప్పండి. చెప్పండి. ఆ, అంటే ఈ రోజు నేను చేయలే కదా. జూమ్లో చేస్తున్నాం కదా మేడం.